Hello and welcome to lesson 2-2. We are looking at conditional, converse, inverse, contrapositive, and biconditional statements. A little bit of this is review because in the summer packet and in lesson 1-3 we looked at conditional statements. And just to remind you, a conditional statement has a hypothesis and a conclusion. And they're if-then statements. So for example, if I am tired, then I will go to sleep. The hypothesis is I am tired, and the conclusion is I will go to sleep. We typically use letters as sentence variables as a shorthand. In the previous example, I'm going to let P represent the hypothesis and Q the conclusion. So P must be I am tired. That's a D, I promise. And Q will be, I will go to sleep. So if we were going to represent these in shorthand, I would just say P arrow Q. All right, let's take a look now at negation. We can take any hypothesis or conclusion and negate each statement. And what negating simply means is to change the truth value. The negation of P would be, it is not the case that P, or shortly, not P. Basically, P means false. And we use a tilde to represent the negation. So, from before, the negation of my hypothesis, well, if you recall, the hypothesis was I am tired, so my negation of my hypothesis would be I am not tired. And the negation of the conclusion would be I will not go to sleep. Okay. Now I'm going to look at the conditional. If it is raining, then it is pouring, and symbolize P as the hypothesis and Q as the conclusion. Well, clearly, it is raining is my hypothesis, and it is pouring is my conclusion. To negate these, not P would be it is not raining, and not Q would be it is not pouring. We can also negate phrases that are already negative in nature. For example, if I have the phrase, I do not have any money, the negation of that would be, I do have money, or I have money. The idea is to simply change the truth value. Now, before moving on, I want you to go online to homework 2.2.1a and complete that before starting the next section. Now we're going to talk about related conditional statements. Each conditional statement is of the form if P then Q, but there are three other kinds of conditional statements we could make with this. Now, conditional is the form that you're used to, if P then Q. Well, the first thing I could do, I could make the converse, and what the converse does is it switches the hypothesis and the conclusion. So rather than writing P arrow Q, it'd be Q arrow P, if Q then P. Now the inverse takes my original conditional and negates the hypothesis and the conclusion, not P then not Q. And the contrapositive is going to both switch and negate the hypothesis and the conclusion. If not Q, then not P. So what does it look like in practice? Well, in practice, let's say I have if it rains, then it pours. That's my P then Q. Well, the converse, I'm going to switch my hypothesis and conclusion. If it pours, then it rains. Because again, it rains is P, it pours is Q. And the inverse is going to take the hypothesis and the conclusion and negate both. If it does not rain, then it does not pour. And my contrapositive is going to flip and negate the first sentence. It does not, if it does not pour, then it does not rain. Not Q, then not P. Another example, if it burns, then it hurts. Sorry, these are really happy examples. I apologize, guys. I'll do something about unicorns next time. Okay, well, converse, flip them. If it hurts, then it burns. Inverse, negate the original. If it does not burn, then it does not hurt. And contrapositive, flip and negate. If it does not hurt, then it does not burn. So the truth values of these kinds of conditionals are not necessarily always the same. So for example, if my conditional is if I live in Texas, then I live in the United States, that is clearly true. There's not another Texas in the United States that I am aware of. Now my converse statement, I'm going to switch my hypothesis and my conclusion. If I live in the US, then I live in Texas. Well, that's not true. That's false. Because I could live in another state. I could live in California. So, or New York, or there are 49 other places we could live, right? Now, the inverse statement, we take the original and we negate hypothesis and conclusion. If I don't live in Texas, then I don't live in the US. Well, again, that one's also clearly false. And we could use the exact same counterexamples again, right? Now my contrapositive flips and negates. So if I don't live in the US, then I don't live in Texas. Well, that's true. If I don't live in the US, then I can't live in Texas. Now, we say that two statements are logically equivalent if they have the same truth values. Up above, the conditional and the contrapositive are logically equivalent because they're both true, and the converse and the inverse are logically equivalent because they're both false. So now I want y'all to do the practice questions in 2.2.1b. Go through, fill out these 3 charts, and answer these 2 questions down here before moving on to talk about biconditional statements. All right, so biconditional statements. You've already encountered biconditional statements in the summer packet, but we're now going to revisit them. The following is a true biconditional statement. Two angles are supplementary if and only if their degree measures add to 180 degrees. Biconditional statements are especially useful because they make good definitions. The statement above precisely defines what it means to be a supplementary angle. This statement could be rewritten as two conditional statements. If two angles are supplementary, then their degree measures add to 180 degrees. And if the degree measures of two angles add to 180 degrees, then they are supplementary. It's okay to make grammatical changes to make the statement work. If we symbolize the first statement as P arrow Q, then the second statement would be its converse, written in the form Q arrow P. We can use the notation double arrow to designate a biconditional. P double arrow Q would read P if and only if Q. Therefore, we can form a biconditional statement anytime the conditional statement and the converse statement have the same truth value. That's your big idea. Okay, circle it, highlight it, whatever you need to do. Now, I want you to go through and look back over the work you did in 2.2.1b. Which of these examples could form a biconditional? And below, I want you to write the biconditional below and then complete 2.2.1c online. Thank you very much for your attention, and if you have any questions, please feel free to come in and ask. Have a great day.